Hi, here we are in lesson 3 of module 6. So let's get started. They are calling this module or this lesson interpret rate of change and initial value. And they say I can find and interpret initial value and rate of change. So let's look at the spark you're learning. Bonnie has decided to join a gym for the next 3 months. Fabulous Fitness charges $45 per month. Greg's Gym charges $99 at the end of each quarter. How can she compare the two options to determine the better value? So they give you some ideas here, make a table, make a graph. So they're asking you to get some graph paper and use a pencil and kind of figure those things out to compare. Turn and talk, what is the rate of change per month for each membership and how do you know? Remember that M is the slope and that is the rate of change, the change in the rise over the change in the run, so rise over run. So go ahead and pause there, work on that, and then we can look at the build understanding. So build understanding, it says many real world functional relationships have only non-negative inputs and rates of change that are constant. You can use initial value and rate of change to analyze such functions. Initial value is the value of a function when the input is 0. A constant rate of change describes the slope or steepness of a graph or how quickly the two quantities change. So number 1 says Bonnie continues to research gym options and finds out that Fabulous Fitness charges no sign-up fee. So you're going to use these facts here in this chart. A little bit of an interesting chart or table there, but it's still a table. While Greg's Gym charges $50 for a sign-up fee. She makes the following table to help compare her two options. So for A and B, use the information that she has here to do those two. And then C and D, C says use an equation to calculate the total cost for 3 months of each gym option. Show your work. And then D, in the equation y equals mx plus b, the slope m represents the constant rate of change or cost per month. What does the y-intercept b represent of the graph of the function? So if you did a graph over here, that would be helpful. If you didn't, you can make one now using the information here in the table. And so pause the video and work on those, and you'll use this information for C and D as well. Then Turn and Talk says, why is it important to consider both initial value and rate of change when modeling functions in the real world? That'll give you something to think about, talk about after you complete A through D. So pause and work on those. Okay, so let's now look at the step it out. The owner of Fabulous Fitness wants to buy name tags for her staff. She writes the following linear function to help represent the cost y for the quantity of name tags x from an online vendor. So here's her function, y equals $2x plus $7. What is the rate of change? And remember, the slope is the rate of change in a function, and the y-intercept is the initial value. That's where your x-coordinate or your input equals 0. So that should help you with these two. And then C, the function representing the cost of the name tags purchased is shown in the graph. So they give you the line, they graph it for you. Complete the coordinates of the point shown on the graph. So they give you the x-coordinate and they want to know what's the y-coordinate for that. Explain what this point means. Substitute 25 for x in the equation and solve for y. So they give you some help there. F, what point represents the values in part E? So now you're going to write an ordered pair for that point that you figured out here. They tell you substitute 25 for x and you're solving for y, so you should be able to find this point. What is the meaning, excuse me, of that point? And they have you fill in the blanks there. H, how many name tags can the owner purchase for $93? So they're giving you a different way to think about it. And you can use the graph to help you. You can use the equation to help you as well. I, how did you determine the answer to part H? And then J, is this function discrete or continuous? So would it be better represented by a line covering every single point, or would you do separate points for each ordered pair. You wouldn't have any in-between points. So you want to answer that. So go ahead and pause there and work on number 2. Then we can go ahead and look at number 3. Okay, if you finish number 2, let's look at number 3. The following table shows how the value of a new car depreciates or decreases over time. So here they give you a table to kind of show you that progression. So time in years is the input, value after each number of years is the output. So they ask you what's the purchase price of the car. So you should be able to look at that and figure that out from the table. B, calculate the slope using these 2 points, 1, 20,000, so this point, and then 3, 17,000. Remember, again, the slope is the change in the y value over the change, the ratio or the comparison of the change in the y value to the change in the x value. And then they say in C, calculate the slope using these 2 points. So they're just having you do the slope in 2 different parts, 2 different areas, or what would be 2 different parts of the graph. And then D, you're going to compare those 2 slopes. What do you notice? They are or are not equal. So you'll circle 1. And then E, explain whether or not the depreciation of the car is a linear function. The change is or is not constant. So the depreciation is or is not a linear function. So go ahead and think about that one and answer E. Once you finish number 3, you can go on to the check understanding and work on that. If you finish the check understanding and you feel good about it, you can go ahead and do the on your own independently. Then if you complete the on your own and you feel great and you don't need any more practice, this is optional, the homework. And then I always encourage you to do the test prep and the spiral review for each lesson. So that's the end of lesson 3, and we will see you in lesson 4.